Good afternoon, good morning, everyone. My name is Alessandro. I'm Technical Manager at CFD, and today I want to guide you through a quick overview about the last update with the last release of the Ansys software. Let's say with a multi-physics approach, not just related to my topic, that is CFD. So let me start from here. So this is, let's say, something coming, a recall maybe from the David presentation earlier today. So he was mentioning this line, engineering what's ahead. So if you look as of now, what's out there in the market, then we can find clearly a few trends there. So for example, digitalization, digital transformation in the industrial Internet of Things, electrification, 5G communication, autonomous vehicles, next generation energy with a special focus on decarbonization, for example, personalized healthcare. So if you look at this, then we can see clearly there is a lot of potential, a lot of power up, let's say, but we need to look forward to that. We need to, apply something that is allowing us to see the future. So we need some superpower here. Simulation is the answer to that. We have a superpower to see in the future how our products will behave in these specific applications to be competitive on the market. So Ansys provides, let's say, a holistic simulation solution that can cover everything from the product ideation to the design, to the analysis in the manufacturing process during the operations, and also the validation and the implementation. So we can get it covered completely using simulation with Ansys, basically. And you can see here that at the bottom, let's say on the ground, we have a solid solution with a lot of tools available to address all these kind of challenges. So we have multi-physics approach that can be exploded in this slide, for example, where you can see all the physics-based simulation tools, let's say the most popular ones, if you think about physics applications, like structural analysis, fluid dynamics analysis, electronics analysis, but it's not limited to that. So basically, we have a set of tools that allows us to go from the nanoscale of an electronic component, like here, to the digital mission engineering. So in aerospace and defense application, or also in oil and gas monitoring. So, and on top of that, we have a set of tools that allows us to go on the cloud and to process and process and manage the data as per the previous presentation by Anne and Johan. Of course, in a multi-physics approach. So everything is there. So this is an overview about the Ansys product portfolio. All the main physics are there, as I mentioned, and as you can see here, there are so many products. So the effort in the development in Ansys is going to give you more and more options, features, capabilities through all these simulation tools. For electronics, fluid dynamics, and structures. As you can see, there are so many, and we have a little time to go through them. So let me guide you through the Ansys 2021 release update for the main application. Okay, so I'm a CFD guy, so let's start with CFD. So we can look at Fluent, for example, and there are many enhancements here. For example, user interface. So there is a lot of new options for customization, to customize, for example, the view. The dark theme, for example, is one of them. So, for example, improve the user friendliness of our graphical user interface, or to apply energy saving options, for example. Of course, we are eco-friendly, so we want also to improve that. So why not? Another kind of improvements related to expressions. So there's a lot of new features like improving the readability of the expression using different colors or text style in order to highlight what we are doing, what kind of information we need to input. So new reduction functions, accessibility to new information and application for boundary condition or post-processing purposes and stuff like that. So more flexibility and applicability of expressions. Embedded windows and hyperlinks. So again, in terms of usability, we have this option available where new plots can be embedded in some windows. So we can track during the runtime what's happening in terms of monitors, both in static or static images or during the capturing of the animation frames, for example. Reporting. So we have a new capability for the generation of results reports. This is completely customizable, so we can use several, let's say, 3D interactive plots, add or hide section of the report. So everything is completely customizable in this way. And at the same time, we can export all this information, for example, in an HTML file or a PDF file. So we can export all this information automatically, and we can have a more impact. Let's say we are going to present the results of our simulation as analysts. Moving forward, if you look at the Fluent meshing development, because this is again a new, let's say, a very important task when you're dealing with the simulation, pre-processing and mesh generation is one of the main tasks we have to fulfill. So we need to have, let's say, more usability on the meshing tools, and this is something that has been done in the last few releases on Ansys Fluent meshing, basically changing the settings for the clipping plane. Before was just aligned to the axis. Now it's completely flexible, so we can put it as we wish. And there are a few advancements also for the, I would say, the progress bar. So it's a, let's say, a smarter way to give this, to get to this information. So based on the experience, the progress bar itself is learning something. So it's getting more and more accurate with time using different simulation approaches. So this is another interesting thing. And the common fluid formats, CFF formats, are completely extended. So we can save and load H5, HD5 format mesh files. In terms of transformation, we can extrude volume mesh. For example, on the inlet section, on the outlet section, we can extrude normal in the direction normal to the boundaries. This is especially used in case we want to stabilize the boundary condition, especially for pressure boundary conditions. So we might need to extend a little bit the domain, and this in the past was requiring to go back, change the geometry, remesh the model and everything. But now we can simply add an extra task in Fluent meshing in order to, you know, extrude a little bit out of the boundary condition in order to get this stabilization of the boundaries. Volumetric mesh transformation, something is there in terms of simplify the workflow when we are dealing with complex geometry, for example, like heat exchangers or turbo machinery or battery model, for example. So we are gonna mesh or model a single module, and then we can replicate directly in Fluent meshing the continuity, the whole object. So this is an operation that was requiring a lot of efforts before, and now is completely integrated into Fluent meshing. When it comes to the solution mode, so we are switching to the solver, then we have a lot of advancement in multiphase. As you can see here, there's advancement or enhancement in volume of fluid applications. So there is a lot of improvement to get to high fidelity solution with improved adaptive time stepping and interface tracking. So this is specific for this kind of application. As I mentioned at the beginning, there are a lot of trends, and we are trying to address all these trends, especially if you look at the electrification, the automotive electrification, the aerospace electrification. There is a lot of application related to gearboxes. So a lot of developments in this area to address fast spinning gears, splashing, this kind of multiphase with all these gears and all these details of the flow. So there is a lot of efforts in this application to improve robustness, accuracy, and speed up of the solution. In the same way, if you look at the DPM, so this discrete particle model, again, a lot of improvements here for better accuracy and HPC scalability. So high fidelity tracking in case of dense particulate and overset meshes. And on top of that, scalability. So pushing harder for complex systems, large count cell domain. So we have get it covered with this new application, new solutions. Something new is related to transition modeling. So some of you probably is already aware about the VOF to DPM application, where in a seamless way we can make a transition between the volume of fluid and DPM. So for example, when we are generating particles from a breakout of a liquid fuel, a liquid jet or something like that, that is something that is already there for a few years, like 3 or 4 years at least. Nowadays, with the last releases, we can cover all the transitions from VOF to DPM to Eulerian or Lagrangian wall film bidirectionally. So we can change that, we can track all the transition modeling from VOF to DPM to wall film in a single simulation, as you can see here. This is an application where we have a spray with DPM, wall film formation, again, droplet formation, and then again impingement to create a wall film and accumulation in this area where we switch to VOF. So everything is done in a single simulation. So it's much easier now to deal with this complex phenomena that again are typical, for example, for application like this. Other improvements, for example, for the GenTop, for the generalized two-phase flow modeling, new improvements in terms of robustness and speed up. Additional models for bubbly flows and boiling flows. Population balance modeling, so new size calculator toolkit for the PBM. In terms of erosion, further developments to implement, for example, the DNV erosion model. This is something useful, for example, in oil and gas application when we are dealing with production and transportation. So in order to take into account the erosive wear in piping systems, we have also this new capability in the software. Heat transfer and combustion, a lot of developments here. So to accelerate the transient conjugated transfer. Combustion modeling. In combustion modeling, again, a new trend, a very strong trend nowadays is the decarbonization. So there is a lot of improvements here. For example, the flame generated model has been completely revamped, and there are addition of new fuels like diesel and jet A1, for example, for the particle injections, and everything is done in this frame of decarbonization. So there is a lot of developments also for hydrogen combustion, hydrogen blending, and so on. Another important things to mention here is the full integration of Chemking Pro in Workbench. So now we can drive all the input parameters of Chemking Pro in Workbench. That means input, that means we can get the output, so we can run simulation in an optimization frame, design of experiment frame, sensitivity analysis frame, and on top of that, because of Workbench, we can run through the remote solver manager on a remote computational resource. Development on battery modeling. This is another trend, again, for electrification. So direct exposure of the battery modeling in the graphical user interface. Before was just an add-on. And because of this integration, we have direct access to new capabilities and simplification of, let's say, the workflow for the battery modeling. So there are virtual connection, standardization of the UDFs, and so on. HPC, a lot of improvements here to speed up in terms of linear solver, I/O, definition of the interfaces, and sliding meshes capabilities. So when we are dealing with transient multiple reference frames, again, we have something like 25% speed up. Linear solver improvements, averagely speaking, we are gaining 5% just switching to the new release. And of course, input output is something very important. So the new CFF format, the common fluids format, are allowing us to speed up tremendously the IO time. Let's move now to the structural side. So in terms of structures, there's a lot of implementation, mainly in Workbench for the full integration of the many products available. So let's start looking into the meshing. So there are new options available for repair topology controls in order to defeature the geometry at a mesh level instead of going back, change the geometry, and let's say waste our time in doing that. New capabilities of freeze and unfreeze the mesh through the geometry branch of the tree. So basically here we can freeze the geometry and force the mesh, freeze the mesh in order to, let's say, save some time when we are changing some parts of our assembly, some bodies in the assembly. So in this way, we can speed up the process here. Operation of extrusion and revolution, basically starting with let's say a sheet body, then we can use a pull feature as a mesh aided operation in order to create this kind of 3D meshes. So start with a 2D mesh, and then we can directly extrude in the rotational direction or in the translational or rotational, let's say, pull features in order to get the 3D mesh done in this way. So it's very easy and very fast. Another advancement or enhancement in terms of system coupling, coupled field, new, let's say, systems available in order to take into account complex physics, like the ones dealing with piezoelectric components, for example. So piezoelectric materials, there is, let's say, a long interest, a deep interest now in this kind of materials because of this electrification trend. So nowadays we want to solve this kind of problem. So we have to add extra degrees of freedom, not just to the structural side, but also for the electrical part of it. So we need to have this complexity included into the picture. So before it was done in a different way. Now it is integrated in Workbench. So we have specific system coupled field for model analysis and harmonic analysis. So something new here, something that allows us to go beyond. New contacts. So new contacts capability, for example, the projected 3D line to surface contact technology is now available. So in this way, we can, let's say, optimize all these processes that before was giving a lot of issues. Thickness. So now at the outline tree level, at the geometry level, we can use the thickness scoping. So basically, we can add the thickness at elemental level. So if you think of it, before you were just going, decomposing the geometry and apply at the shell level, a different thickness to different parts of your device or equipment. So now we can go element by element to do this, to give a distribution of thickness at element level. So basically, you can see a lot of benefits here in the definition of problems related to erosion and corrosion. Another advancement is related to the post-processing. So in the post-processing, now we have a lot of details like moving objects. So when we are magnifying the amplitude of the displacement, the probes are following the geometry, the deformation of the geometry. Before it was not like that. Other advancement in LS-DYNA. So implicit features, this is an important feature to mention. So there's a lot of flexibility added here. So we can switch from implicit to explicit in LS-DYNA directly to the Workbench. Advanced restart. So now we have a separate branching of restarting points. So we can add flexibility to add, for example, more parts in the restart. And smooth particle hydrodynamics enhancement. So we have a dynamic and automatic conversion of eroded elements into SPH particles. Improvements also in the arbitrary Lagrangian invariant to handle large deflection, large deformation in both structured and unstructured ways. So from 2021 are to all, both of them are available. A lot of enhancement in the context, especially for SPH applications. And something I want to highlight here in electromagnetics. So solver enhancement also in this field, for example, here, including models for the thermal runaway. It's not moving. Okay. Yes, additive solution. We have new improvement for the additive solution in order to speed up the solution, also for the microstructure simulation and more models, improvement in the modeling to increase the accuracy and the robustness. In Ansys Motion, a lot of developments here to deal with the contacts, so to improve the performances of shared contacts. Saw interaction, planetary gear, so new toolkits available here in order to address this kind of problems. Simulation scenario where we can change, let's say, the execution, stop the solution, activate joints, and so on, based on the solution time for some functional expression, for example. Ansys Sherlock. So there's a full release of this plugin, so complete workbench integration, so we can transfer easily all these settings from Sherlock to Ansys Mechanical or LS-DYNA, for example. Everything is there, and new theory guide is available. For HFSS, so we are moving to electronics. So new breakthrough technology, mesh fusion workflow. So basically, before it was not possible to simulate different components at a system level. Now everything is possible in this way, so we can integrate several components belonging to the same system and run a single simulation to account for all of them in the same simulation. So this is a breakthrough innovation, if you look at that. Improvements on antenna arrays, from pre-processing to solution to post-processing. Automatic PAC cap for wave ports. So this is something that was requiring a lot of effort before, but now is kind of simplified. Parametric array conformal shape and volumetric 3D dielectric, so SBR plus here. So we can take into account, let's say, 3D shaping of the objects in order to account for the effect of those dielectrics. And new Hertz filter solution. This was a third-party tool that now is fully integrated with the Ansys electronic desktop. So it's like plugged in directly and can use to define and design, let's say, filtering solution for HFSS. Maxwell, advancement in the definition of skew model advancement that will allow us to speed up the solution in terms of 3D approach with the speed of a 2D simulation. Nonlinear impedance boundary supporting 3D transient, so we can change. There's a, let's say, innovative methodology to solve this problem in a very accurate and quick way. And new features for temperature dependent demagnetization DH so we can take into account the temperature dependence here. With IcePack, so new features for native joule heating in the Ansys electronic desktop. A new workflow for, let's say, new toolkit actually for ROM specification. Solver improvements for NCAD operations and solutions. And a SI way to IcePack data link. So it's a seamless connection now in Workbench to take care about this connection. Acoustics. So we have improvements, general improvements in acoustics with new modeling in Fluent, new modeling in Mechanical. So air acoustics and vibroacoustics, let's say, generally speaking, have been upgraded in both the flagship products for CFD and FEA. There is a new workflow, DAVA, deterministic aerovibroacoustics. So it's a full integration between Ansys CFD and Ansys Mechanical to run this kind of complex simulation, for example, cabin noise generation and so on. Another important thing to mention here is an integration of VR experience sound analysis into the flagship products. So basically, you can run a simulation and hear the sound generated by that directly into Fluent, for example, into mechanical, into Ansys Motion, and so on. So this is an important thing that is addressing this acoustic problem. Ansys Piers, many evolutions here, productive enhancement with new libraries, speed up of the meshing process, live preview to see in real life how it looks like. So 100% true to life experience here. Optical design flexibility, new options, new controls for TIR lenses, total internal reflection lenses. And then we have extended sensor simulation capabilities. So dynamic LiDAR simulation are now possible into spheres. Twin Builder, some new advancement modeling with the Modelica. So we can copy, duplicate, export FNU binaries for Win32 platform, so 32-bit platform. That was a request for a long time. ROMs, advancement in ROMs, advancing in generation, visualization, and interrogation of the ROMs in a single environment. New advancement also for the exporting, so to the twin deployer has been enhanced to get this real-time 3D visualization during the simulation of the ROM. And of course, an expanded ecosystem with a new digital, a new support for digital twins solution by Microsoft Azure and the Rockwell Studio 5000, and Linux extension for PC TeamWorks as well. And with that, again, engineering what's ahead is there, and with 2021 R2, we can get closer and closer to that. So with that, thank you so much for your attention.